Differentiating rational and irrational numbers. This example comes from the OpenStax College Algebra textbook. Our instructions here are to determine whether each of the following numbers is rational or irrational, and if it is rational, to determine if it is a terminating or repeating decimal. First, a quick review. Recall that the set of rational numbers includes fractions that we can write as m over n, and also that rational numbers will be either terminating decimals or repeating decimals, where we have some sequence of digits that repeat. And then irrational numbers are all of the numbers that are just not rational. So with that in mind, we'll start with a here, the square root of 25. And before we evaluate whether it is rational or irrational, we should see if the square root of 25 simplifies. And since the square root of 25 is exactly 5, then we can see that 5 is rational, because I could write it as 5 over 1. And if we were writing 5 as a decimal, then we could write it as 5.0, which is a terminating decimal. So the square root of 25 is both rational and terminating. For b, we have 33 over 9, and 33 over 9 is already written as a fraction, so it will be rational, and we'll need to determine if it is terminating or repeating as a decimal. So 33 divided by 9 equals 3.66 and infinitely more sixes. So we would use a bar to indicate the digits that repeat, and the first 6 is the repeating digit. So this is both rational and a repeating decimal. So 33/9 is rational and repeating. For c, we have the square root of 11, and the square root of 11 doesn't simplify down to just a whole number, and any radicals that we can't simplify to remove the radical will be irrational, and irrational numbers cannot be written as terminating or repeating decimals, so we can just label this as irrational. For d, we have 17/34. Both 17 and 34 are divisible by 17, so this fraction does reduce to just 1/2. 1/2 is written as a fraction, so it is rational. Writing 1/2 as a decimal would be 0.5, and this is a terminating decimal, so we would label this as rational and terminating. And since this last example is given to us as a decimal, if we can determine that it is terminating or repeating, then it would have to be rational. Based on the ellipsis at the end, the decimal does keep going, so it's not terminating. Is there a sequence of numbers that repeats itself? And at first glance, it looks like maybe there is. However, the pattern doesn't exactly keep repeating itself. For example, we have a 3, a 0, and then 2 3s, a 0, and then 3 3s, a 0, and then 4 3s. So at no point is there a sequence of digits repeating, and if it's not a terminating or repeating decimal, it has to be irrational.